Our next speaker is Jonathan Waterston. He will talk about Erl6, static versus dynamic. So I think he has something very interesting to say about it, so something new. Thank you.
I admire your optimism. I'll attempt to have something interesting to say. It's great to be at FOSDEM again and to see such a full room. Who was here last year for my session? Just out of curiosity. Okay, I didn't scare everyone off who came last year. That's some achievement at least. Okay. So, hi, I'm Jonathan. I like cold places. This is my vacation on a glacier. It was cool. And so I am one of the folks who works on the Perl6 compiler stuff, which means that in many ways I'm one of the folks who probably is going to get lynched if we don't actually cut 6.0 this year. So I'm developing plans for where I can go into hiding and all of these things. But actually, yeah, that's a good advice. Yeah, no, but shave, yeah. Shaving would probably also work. The primary plan is actually to deliver Perl6. Anyway, so I work a lot on of course, the Perl6 compiler and the MoreVM runtime. I also do some other bits of work. In many ways, I guess I'm a bit of a language polyglot in the programming language sense. And actually, when I was preparing this talk, I sort of thought back over the last year, what languages did I actually deliver code in that people used? And I realized it was a little bit of a list. And people actually even paid me to do some of these. I actually wrote JavaScript without getting paid for it. That's kind of something. Yeah. No, it was because I was writing the UI for the Perl6 profiler. And it's really, really slow because I didn't want to learn JavaScript, so I used Angular.js. So it looked beautiful, and it works really slow. So yeah. Anyway, if I take these languages, and I was to do a little survey, okay, of whether people would call them static or dynamic, I think I would probably get answers like this. Okay? Anyone want to heckle, disagree? No? Okay. So even though these terms are, to me, very woolly, not very well defined, we tend to sort of be pretty good at putting languages into one camp or the other. And having worked with these languages over the last year, I can say that they have benefits and drawbacks, and they've been debated plenty, and I don't really plan to add fuel to that fire. But I can say that I felt the pleasure and pain that comes from both sides. And I'm not really here to talk about what's best. There's plenty of places on the internet you can go and do that, okay? Just search for is static better than dynamic and is dynamic better than static, and you will have, weeks and weeks of stuff to read. However, what I do like is the times when I can sort of have my cake and eat it, okay? And one of the things that excites me about Perl6 is it feels to me like one of those languages where a lot of the design calls that have been made and a lot of the things we have kind of are putting us a bit into this kind of position. So let's start out writing a little bit of code. I'm only going to do a few small examples in different languages, okay? So this is hopefully kind of easy code. We declare a variable. We assign something into it. We do some bit of I/O. We have a load of crappy boilerplate around it. What is this going to do? And what's going to fail? It's going to fail to compile, okay? The C# compiler is going to say the name moroning doesn't exist in the current context, okay? And, well, fine. So it's another day, and I'm writing Python. The Ruby is about to say. Actually, when you start looking at comparative bits of code, sometimes you realize it's really easy to be a programming polyglot, okay? And but what are these going to do? Does anybody know? Here we're thinking about it a bit. They might fail. Yeah? Any other suggestions? printing what? Print undefined. It will fail, someone says? Yeah. So actually, when will it fail? Runtime. Bingo. Okay. Looks like that. So this is almost sort of what I call sort of reckless dynamism. It's kind of the sort of thing where we really put stuff off until runtime. And of course, if we take vanilla Perl 5 and we feed a similar program in, then we're going to get kind of the same. And of course, we don't do that. We put ustricts on the top, okay, and it tells us a compile time. So here's an unadorned, without any ustrict Perl 6 program. What is this one going to do? It's going to print opening hours and then crash. Okay, that's one idea. Anyone else? It fails during compilation.
No, you don't have stricter warnings. It's not going to warn. It's going to print opening hours, new lines, and then it's going to print opening.
But it's Perl 6. Read the slides, man. Yep. Yep. So what happens if I feed this to Perl 6? It fails during compile. Okay. And I mean, seriously, what the heck? Look at this thing. It said sorry for my moronic typo. I mean, it's almost Canadian levels of polite here. And then, not only did it say it was sorry and that I screwed up, it went and looked at what variables I did declare, and it said, oh, maybe you meant morning instead of morning. Yeah, I probably did. And just to sort of help me out a bit, because maybe this happened inside a nice long line of code, it has a little sort of green-red thing, okay? And it sort of says, I was happily passing, and it was good, and I was happy, and then I ejected here, okay? It's the eject symbol from an old cassette player. And everything beyond it was sad and red, okay? So it points out exactly where on that line the problem was. Well, that's kind of nice. And this is just one of many, many examples, and I'm going to show you today, where in Perl 6 we've thought very carefully about what sort of things it's possible to know and complain about at compile time, what sorts of things we really should make very dynamic and leave unresolved until runtime, and then for all of those ones that we, by default, will tell you about at compile time, we sort of also provide you a little escape valve if you really, really need it, okay? So one of the things that has been really sort of coming back to us again and again throughout the Perl 6 design and implementation process is just how valuable lexical scoping is. What do I mean by lexical scoping? Well, it's just a fancy word for saying thingies between curly braces are a scope. And anything that you declare inside of them with my lasts until the closing curly, okay? So in here, you can see I've got that little green scope on the outside. I've got this purpley one, okay? And at the end of this purple one, then we got rid of some now. We got rid of average. We can't talk about them anymore, okay? So it's not just variables, though, that are, it's not only, by default declared lexically with my and resolved lexically, but it's also subroutines. So in Perl 6, when you write sub, abbreviate there, what you're actually kind of saying, really, if you wanted to put it in Perl 5 terms, is my sub abbreviate. And we haven't just made sub declaration lexical, we've made sub resolution lexical. So what happens is when you call a subroutine, we go and we look for it in the current lexical scope. And if we don't find it, at the end, we come back to you and you say, by the way, you used this abbreviate, spelt in a kind of abbreviated way, at line 6 there. Did you mean abbreviate spelled properly? Okay. So this is just another place where, by saying, well, subroutines are, lexical by default, we'll look them up as lexicals. We get a whole lot of ability to point stuff out at compile time. Now, you might at this point have some objections, like how do I do X? Okay, and we'll come to those in just a moment. Now, staying on this example, though, there's a few more things that could go wrong. I mean, if I'm having a bad day, I'll typo things. But if I'm having a really bad day, I'll forget one of the arguments, okay? And because we can actually resolve, as we compile this program, what you're calling, we can take a look at this call. And we can say, wait a minute, you're passing a single argument there. But up here, this sub has a signature and it says it wants 2. We're going to tell you about that at compile time in this case, because we can. There's no point letting. Sorry? I forgot to put the what back where? Did I really?
Yes.
That was bad of me. Fail.
You get all the errors back, or do you just get one compile error back?
You actually get a load of them back. It collects them. So we classify parse errors and compile errors into 2 categories. We have panics and we have sorries. Now we say we're sorry about all of them because just shouting panic would be really, really bad, okay? What we do inside the compiler, though, is we actually distinguish them. And panic means we were passing the program, but we can't possibly go any further because we're too confused. And we'll just start spewing meaningless errors trying to guess. But in other cases, we spot a problem and we're like, this is definitely a problem. We won't compile the program, but we're still in a good state and we can keep passing. And we actually distinguish them, okay? And we don't actually stop collecting errors until we hit something that's a panic. So it's kind of a nice trade-off between the two, okay? Because I've seen cases where, I love this with C compilers, okay? I make one little mistake and I get 100 errors for it. And it's like, come on, show me the first one. So I can actually even take that one step further. Because let's put in some types, okay? So there's a string. That's got to be an int. What's that going to happen now? Well, it can actually even look at this, and it can tell me, you know, that's definitely an int. I can see it. It's a literal, okay? It's really obvious to me as a compiler. And it's really obvious to me this is a string as well. So your program is never possibly ever going to work, okay? There is no way you can ever make this subroutine call and have it work at runtime, no matter what you do. This is just never, ever going to happen. And we can point that out. Now, there's only so many cases we can point this out so far. Okay, we don't do a lot of crazy inference. And we're being very careful about this, because in this case, we can explain to you what's going on. Okay, we can say you called it with an int and a string, and it wants a string and an int, and you can go and look at it, and you can say, oh yeah, I did. What we do not want to do is get to the point where we spit out this huge sort of massive mathematical proof we did of why your program won't work, and then you sort of look at it and you're like, I better get a PhD before I do Perl 6. Okay, so that's not the goal. So we're trying to sort of balance out telling you stuff without sort of going overboard and being able to understand, you know, what we're actually saying. But for this one, we catch it. Little curiosity for you, by the way. You might be curious. Can anyone guess what bit of the compiler actually figures this out? I know. You know. You know. You work on the compiler. That's cheating. It's actually the optimizer. And that sounds really weird, but the optimizer is trying to prove properties about your program that help it to optimize it. And occasionally, as it does so, it proves your program could never actually work as a side effect. Okay, so we kind of get 2 for 1 there. I like that. Now, I said that this is all a product of lexical scoping, but I kind of only told half the story. Because what's really going on here is that those subroutines that you add and those variables you declare, of course, they exist at runtime, but they also sort of come into being at compile time as we compile your program. And that is why, by the time we get to the end of the load of code you've written, we can start reasoning about it. So whenever I see a line of code like that, okay, that is take an array of readings and the plus there is the reduction meta op, okay? It's like putting plus between all the array elements, and you get the sum out the end. What we actually do is we kind of break that into two things. We say, well, you've done a declaration, okay? That is, you have said that in this scope there exists a variable sum, and that is something that we'll need a bit of space for at runtime as well. And then at runtime, of course, we make, every time you enter the scope, some space to store that variable, and we run the assignment at the place you wrote it. But all the time when we do these things, we're sort of picking the two apart and saying, well, what does the compiler need to know, and what's going to go on at runtime? Okay, so declarations in Perl 6 are very much a compile time thing. Just as a historical aside, this idea of compile time, runtime, and objects that sort of exist at compile time, sort of going over to runtime, was one of those things that really took me quite a while to get to terms with. Because when you go off to compiler school, okay, well, computer science classes, you go off to your compiler class, and they sort of teach you that there's a compiler which does all the work at compile time and spits out a program, and there's an interpreter which sort of chugs its way through code. What you kind of understand a lot less out of that is sort of all the possible shades of gray between. When I teach software architecture, I often show my students a graph like this. This is the ignorance graph, okay? It's the idea that when you start working on something, you're at a point of maximum ignorance about it. And over time, hopefully, it decreases. And a lot of the time in a project, you kind of have a sort of aha moment where you understand something about the very core of the problem you're solving. And for me, with the Perl 6 compiler stuff, actually this sort of compile time, runtime boundary stuff was one of those things where I kind of realized, aha, that's the reason that so much of our code in the compiler is really convoluted. Back then, if you actually wanted to, just take a symbol that was going to exist at compile time and try and set it up at runtime, we solved it ad hoc every way. And it wasn't until I realized that's a really common thing. That happens all the time. And of course, nowadays, that's a one-liner in the compiler. And it was one of those places where, it was very much a lesson learned. Now, okay, let's talk about classes. So classes are also declarations. And that means that when we write the class keyword, and we start writing methods in there and adding attributes in there, stuff starts to exist at compile time. And that provides us with a whole load of quite interesting opportunities. So let's talk a bit about method calls before we do that, because that's kind of one of the reasons you write a class, okay, to end up calling the methods on it. That's kind of the point. So this is one of the things that in Perl 6 is late bound. Okay, these are things that are resolved at runtime. It's completely up to the object that receives the method call to decide how it's going to handle it. And that's very much in the spirit of the way that, OO works. So, if I write something like this, okay, this is a runtime error. You can tell because we're not sorry about it, okay? You laugh, but it's a really good visual hint. Okay, you get very used to this when you're writing Perl 6. If it says sorry up there, you know the compiler is telling you. Okay, if it's not there, you know you made it till runtime. It's one of those things that after a while you just take for granted, and it helps you understand, what do I need to do. Now, in this case, okay, we have a class, we have 3 fields, okay, and we make an instance of it. We call a method that doesn't exist. Okay, that's clearly a runtime error. Now, that object there, of course, it has a fairly fixed set of methods it could handle. But we're very, very dynamic about the whole method thing. There's a lot of things you can do. And one of the easiest mechanisms we provide for this is the magical fallback method. Another general design rule in Perl 6 is if something is in uppercase, it's something that Perl will call for you in some kind of circumstance. And fallback is one of these. So we can write a horrible little HTML producing class here, okay? And what I do is I say HTML.p, and it goes off and it tries to call a p method on this class, and the class is like, I don't know how to p. So what then happens? That came out bad, didn't it? Okay. So at least you remember the example. So what happens is we end up in fallback. And the first thing that we get is past the name of the method we tried to call. And then we get past the arguments that we tried to call it with. And what I'm going to do is I'm going to slurp all of the positional ones up into an array. I'm going to slurp all of the named ones up into a hash. And then I'm going to do some horrible string munging and produce a bit of HTML. And you can see that, okay, in this case, the P tag is getting free children. Okay, and for the A tag, we've used a named argument there to get the attribute in. Okay, and of course, don't actually do this without going and hooking it up to something that knows how to HTML encode content. Otherwise, you'll get a wonderful cross-site scripting bug. But you know, it kind of shows the idea and that an object is very much in control of the destiny of method calls that head its way. And this is just one way of being able to sort of decide what to do with your method calls that you can't actually handle. So we make method calling a very sort of dynamic thing, and one of the ways we actually thought about that in Perl6 is linguistically. We tend to consider a lexical scope as being your language. It's the language you as a programmer are writing in, and when you declare things in there, you're adding words into your language that you can use and speak with. When we make, you may.
The fallback, is it also called when using new?
When using new? No, because there is a new method because you inherited it.
No, I mean when you have attributes inside new, normally it would use setters.
Yes, it doesn't though.
Okay.
It actually assigns to the attributes directly. Yeah, so no, not in that case. Yeah, so yeah, the method has to not exist in any of your base classes. But yeah, the way new works is it actually assigns to the attributes, not calling their setters. So, yeah. Okay. Yeah, the general principle is, lexical scoping is all about your language. Okay, and you choose what you import into it. You choose what you declare there. And it's something you're very much in control of. And this is again a very general Perl6 principle. We always know what language we're in. So if you declare a new operator or you import a module that does add new operators into the language, well, that's just fine. But at the end of that lexical scope, the parser isn't going to recognize them anymore. Okay, we keep all of these things very lexically constrained. But when you're talking about an object, the idea of objects is they're a point of decoupling. They're a point of inversion of control where you say, I want you to do this thing, and, I don't know how you're going to do it. I'm not going to define how you're going to do it. But, here's something I'd like you to do, and it's up to the object to interpret what the words you tell it in the method calls actually mean. And that's a lot of the power of objects. They're very autonomous in that way. So method calls are one of the things about classes that inherently we really want to leave as a very dynamic thing. But there's a few other things in classes that maybe are a little bit more lexical, that we can figure out by looking at what's between the opening curly and the closing one. So what is this one going to do? Yeah, that's a compile time fail. Okay? It's going to say the attribute start here ain't declared in class war. Okay? And how about this one? Yeah, compile time fail again. Okay? Because this time it actually also goes, and this is quite a it's sort of a common-ish mistake. I don't make it that often, but it gets made now and then, and that is forgetting the twidgel. Okay, that exclamation mark there, and it says this is actually an attribute of the class I'm interested in. And what you've actually got there is just a normal lexical lookup. And we actually catch it, and then we actually go and when we catch these and we're inside a class, we go and check what attributes the class has and say is the one that matches and suggest it if so, because it's one of those ones that people tripped up enough on that it's just kind of nice to point it out. So, and this is one of the advantages of the Perl 6 compiler being written in Perl 6. This actual error message addition was contributed about 1 month ago by someone who tripped up over this too many times and was like, damn it, I'm going to patch the compiler. So, and we do pretty much the same for private methods too, okay? So a private method is a method that you can call anywhere in the scope of this class. If you want to call it from further elsewhere, you can tell that your class trusts another class, but don't do that, okay? So what I've got here is, I decided to refactor my code, so I wrote a little private method. You can see the exclamation mark there, tells you it's private, okay? I've called it date range, and it just makes a range from the start year to the end year. And then I want to call that private method, okay, with the exclamation mark, and I go and smart match it against the year, and it checks if that falls within the range. And of course, you can see what I've done here. I've gone and called a method that I didn't have, and again, it can come back to me at compile time, okay, because these are non-virtual, and it can say, oh, you misnamed that private method when you called it, okay? So all of these things, where we've made them, kind of lexical, we have a very good opportunity to tell you about at compile time. And that includes roles, okay? So if you get 2 roles, and they're going to provide something to the class that is in conflict, when do we actually compose the roles? Well, we compose them when we hit the closing curly brace of your class declaration. That's the actual composition point. So as soon as we hit that point, we say, okay, let's compose the roles into the class. And then, if anything's wrong, it's an error. So just to look at an example, okay, we're building a little system for our friend who collects old books and rents them out. So here I have an old book for rent, okay, it does borrowable. So you can see that we can lend it out for a certain duration. It's going to cost a certain amount to borrow it. And then it's collectible. So we know whether it's a first edition and whether it's in fine condition. Okay? So that's fine until one day, we get asked to change the system. And we're told that, yeah, actually, these jerk people who borrow our books don't ever return them in time. So we want to start fining them. All right? So we add a fine here. So does anyone spot the problem? Okay. Okay. And yeah, if you do that, Perl 6 is going to actually complain at you. In fact, I think I've chopped the second half of that error message off, which told you where it came from. So, because I ran over my slide. Okay, but the thing you've been told there is that actually the 2 attributes you declared there are in conflict. And we'll tell you about methods that are in conflict. That's still a normal thing. But if we'd done this with, say, multiple inheritance, what would have happened? Well, no error. And because it just turned out that completely arbitrarily, I just thought of borrowable before collectible, okay, I would just have got the new behavior I put in there overriding the original one I had. No warning, okay, no heads up, system goes off into production, weird things happen. Okay, so this is another place where, at compile time, we can give you that extra bit of safety. So what we're trying to do here is, balance out that, that very flexible method dispatch where you can do pretty much whatever you like with this sort of very, large bunch of checking where we can point out things that you almost certainly didn't mean or that are never actually going to work. Modules give you some interesting opportunities. Because when we hit a use statement, we actually go off and load the module right away. What that means is that at this point, the module actually gets a chance to do some stuff. And it gets to do that stuff in the context of the compilation of the bit of code that is going to do the use. the other thing that we've done, in keeping with all of the lexical default in Perl 6, is we've made imports lexical by default. What that means is that if I have some curly braces there and I say use test, okay, and I do plan 42, okay, and then I close it and I try and say not okay, it's going to come back and say, oh, that's an undeclared routine, okay, because we imported the stuff we needed just into one scope, and after that scope's gone, okay, the symbols are gone. And you can just actually import bits where you need them now. You don't have to sort of do them all at the top of the file. You can scope these imports much more to the places that actually want them. Now, you might wonder, how can we do some slightly more dynamic things where we'd like to generate subroutines? And there's various ways, but modules are one of the really good ones. So let's just write ourselves a little module. I've called it shell as sub. Okay, when it's just a little module where I name a couple of shell commands, ping and traceroute, and what I actually get is a couple of subroutines where I can just call the commands just by calling the subs. Okay, now that's the module. Okay, it's a lot of code. So what we do is we write a sub export, and the importer actually calls this when we use the module, and it says, here are the things, you can see there in commands, that we actually would like to sort of have. And we get to interpret that however we want. And all we need to do is return a hash of the symbols that we want to have installed into the lexical scope of the thing that's doing the importing. So all I need to do is loop over the commands, create this little anonymous subroutine, and that takes some arguments, okay, runs the command, flattens that argument list in there, and then we'll just install it in this hash, stick an ampersand on the start, because that's the way subs are installed, and return it. We're done, okay? And that's it. So the really nice thing about this is that I've just very dynamically gone and generated and produced these subroutines on demand. But what happens if I take the one that I've created there, and then I spell it all the way out as traceroute, like a sane operating system that isn't Windows would do? What's going to happen? Well, I get told at compile time. Okay, it actually tells me here, traceroute used. Okay, did you mean trace RT? Okay, and you might be saying, why is it line 1? And the answer is I did it in a -e, and then when I put it on the slide, I put in a line break. Okay, so I beat you to asking me that time. It's not a compiler book for once. Okay, so that's kind of neat. And you can actually do that sort of thing with classes too. So I told you that when we encounter a class, we make a declaration. What do they really mean by that? What they mean is we go and we actually construct an object that represents that class. And when we hit a method, we construct an object representing that method. And when we get an attribute, we construct an object representing that attribute. Okay, and for all of these things, really what the compiler is doing is it's just producing objects for you that describe the declarations you're making. Now, occasionally, some of us like to sort of sound fancy and clever, and we call these objects meta objects. Okay, but that's all they are. They're just objects that describe something in your program. That's all a meta object is. Now, how can we write a module that dynamically produces classes? Well, the answer is that we just create the objects as the compiler would, and we export them. So imagine I have a little JSON file here. Maybe this is a very simple schema. We're building some microservice. It ships events all over the place, okay? And we have some schema, and we just want to generate classes for all of these message types. And I've got this is oversimplified, but it keeps my example nice and simple for now. Okay, it's got a name of the event, okay, and I want to have a class with that name, and I want my class to have these different fields. Now, what I'd really like is to be able to just use some module, okay, and the module is going to read that JSON file, it's going to produce the classes, it's going to export them, and I can then just use them. And just to show you why it's really important that they exist at compile time if I just go to my REPL here and I say class food, okay, and then I say foo.new, it's actually going to complain and say, oh, you used an undeclared name foo there. So we actually want to know these names exist. Okay, so we can't just really cheat here. So let's have a look at how we do it. Well, what we're going to do is, first of all, just write a little helper subroutine to create classes. And it's going to get a name, and it's going to get the set of values that we want to have attributes for. And we're going to go off to our meta model, and we're going to take a class that's called a class how. And that is how a class works. Okay, and for all of the various things, like grammar, okay, there's a grammar how. Role, there's a role how. Okay, what we do with this is we just say, I want to make a new type, and we tell it that the name should be $name. That colon $name actually is like passing a name parameter, okay? So it's like name arrow $name, but a nice bit shorter. Now, we're going to sort out the attributes, and then when you actually have finished creating a type, remember I mentioned the closing curly of a class? That's when we finalize a load of stuff. Okay, what the compiler actually does is it calls compose on the object representing that class. And this .hat thing is actually what we call a meta call. It's a call not on the object itself, okay, but on the meta object. So it's on the object that describes that class. And so we're sort of simulating that closing curly. And then we'll do a little loop over the things we want to have as attributes. We'll make a new attribute object, okay? We'll say it's a $exclamation mark attribute name. We'll say that we don't care what type of value is stored in there. We'll say that it belongs on the package $type, okay? That is the class we're creating, and that we'd like it to have an accessor method generated. And that's all we have to do, okay? And at the compose, it will actually generate all the accessor methods. So that's how we get a class. Now, next up, okay, we had a little subroutine there. And normally, the way you export things is you put isExport on them, okay, and that's it. But because we're being a little more dynamic here, what I'm going to do is just explicitly put myself in the export default package, which is the default things we're going to export. And then I'm going to use the JSON tiny module. I'm going to slurp in a JSON file, okay. I'm going to from JSON it, which gives me back something. I'm going to actually get it as a flattening list. That's the at the start there. And assign it into this events array. And then I will loop over those, okay? And this thing in the parens here is actually a signature unpack. It means that what we're doing is we're saying, well, I'm looping over an array of hashes, but I don't actually want the hash. I want to pull out the name key and bind it to $name, and the values key and bind it to the array values, okay? So it saves me having to unpack all of the hash. So this is one of the other nice things we do with signatures in Perl 6. Okay, we use them for data structure unpacking. And then I generate the class for this name and values. I stick it into the current package, okay, under name, and we're done. And your only question that might remain is, what is that begin thing? Okay, when Perl 6, you can pre-compile modules. You can actually compile them into, say, JVM bytecode, more VM bytecode, and persist it on disk. And that persistence isn't just the code, it's also all of these objects that we create at compile time. What this means is that at the point that you compile this module to bytecode for the first time, okay, we tend to treat that as a cache, it will go off, it will read the JSON file, it will parse it, it will generate all of these classes, okay? In the future, when you use that module, it won't have to do all of that anymore. We'll have just saved all the classes that we wrote, just as if someone had programmed them by hand in a source file. Okay? So we don't even have to pay the load cost every single time, which is kind of nice.
What happens then when a new event is added to the JSON file and you need to regenerate it?
Then you recompile. You treat it just as, you know, a new version of the module. yeah, at the moment it happens at module install time, and I'm presuming here this JSON file is something you ship with this little wrapper module, and then when you update to a new version of it, okay, new JSON file, we recompile it because it's a new version, and yeah, that's the way it would currently be. Okay, I think we have time for one last thing. So, if classes and roles are described using objects, what if we could actually sort of, you know, replace those objects or tweak those objects somehow? Maybe that could be kind of interesting. Well, let's imagine we're building ourselves a little MVC framework, okay? And we decided we're going to put our routing off on the controller methods, okay? So here I have a controller, okay? It inherits from some controller base class, and I've just said, and the URL template for this action is this, okay? And I'm not a web framework designer, so please don't cry too much. Now, what I want to do is I would like to sort of statically check that when this framework is used and you write methods in a controller, that you actually use the URL template on all the methods, okay? And if there aren't any, we'd like to tell you at compile time, by the way, you forgot a URL template. Can we do that? Well, here's just a little bit of infrastructure. Okay, there's my controller class. That is the base class for things. Here I've got a role, which just holds a URL template. And here I've got something I call a trait. Okay, you see that is keyword. That is there. Okay, you can choose what's going after that. And the way you do it is by writing one of these trait mod subroutines. And all I have to do is say what sort of declaration I want my trait to apply to. So in this case, methods. And then I actually have a choice how I arrange for it to be called, but the easy way is just to put a named parameter there matching the trait name. And what actually gets passed to that parameter is whatever value is in the parens there. Okay? So what I'll then do is I'll just take this role. You can actually use them as mix-ins into individual objects as well. So I'll just mix in to the method, okay, this URL template. And we have this very convenient syntax where if your mix-in has only one public attribute and you put something in parens there, we just initialize it with that. Okay, it's quite a convenient thing that you do pretty often. So what I've just done is I've taken my method object and I've just tacked a little bit of extra information onto it saying, oh, and this is its URL template. So that's how we associate them. How do we check that all the methods have them? Well, what I'm going to do this time is turn to a special package called export how, okay, which is for exporting meta objects. That is, exporting objects that describe how things like classes work. And what I can do is I can say I want to supersede what class means. And I'm going to do that by inheriting from the default implementation of classes. And whenever you add a method, okay, I'm going to intercept that call, and I'm going to do some checking. And provided everything is well, I'll do call same, which just means delegate to my base class. Okay, that is do whatever adding a method normally would do. And then in there, okay, I can actually just go and say, well, if this is a controller, and if the method doesn't have a URL template, that is, if we didn't mix the URL template role into it, then just die and say, oh, this method lacks a URL template. Okay, and what else? Well, actually, that's it. Okay, if I take this and I run it on this code, it comes back to me and it says, hi, this about method lacks a URL template. Oh, gee, so it does. Okay. And you can push that even further. You can actually do stuff where you get to declare your own kinds of declarators. I wrote a module for monitors, which are a concurrency construct where only one thread is allowed to be inside the object's methods at once. And look at the start of this. Okay, instead of writing class, you write monitor. Okay, and then it enforces the mutual exclusion for you. But it gets better, because you have these things called condition variables, which basically are conditions you can wait on. So when I'm putting something into the queue, I can wait on the condition not full, okay? And when someone takes something from the queue, it can say, oh, now we meet the condition not full. But what's really cute about this is if I was to, if I just run this one now, okay, yeah, it starts working, it runs, okay, blah, blah, blah. But here's the thing I wanted to actually show you. If I go and sort of, you know, not fool instead, okay, that one's a compile time error too, okay? What I've actually been able to do in here is actually do a whole bunch of stuff. This one's actually more evil because it's not only exporting a custom meta class. Actually, you can see that down here. Instead of package supersede, I say I want to declare a new kind of package, okay, and it's a monitor. You can imagine doing this for your MVC thing where you can have a controller class instead, you know, so it's controller something instead of class something if you really, really want to. Okay, for the concurrency stuff, it's really nice. We have an AXA one as well. But I actually wrote macros, which are things that run at compile time. So what happens is this meet condition, okay, it checks the name, exists, and then it goes and actually does the getting of the attribute and calls signal on it, okay, which is the low-level condition variable thing. So
Is a macro much faster than a private method?
yeah, a macro runs at compile time. So by runtime, yes. Yeah, but no, it's about when it runs. So a macro gets chance to say, well, you called me, but actually I want you to compile this bit of code into the program instead.
Like inlining.
Yeah, it's just like inlining, just like inlining. Yeah, yeah. So one of the things that you might be looking at this and saying is, whoa, that's cool, but kind of crazy. And the answer is, well, I don't expect that the everyday user of Perl6 is going to be, you know, going and doing metaprogramming stuff. What I think is really nice, though, is that we're putting into the hands of people who build libraries and frameworks the tools to actually deliver a really nice developer experience. It doesn't matter that in Perl6 your MVC framework isn't part of the language, because you can still find ways to get the compiler to do bits of checking on correct usage. Okay, same with the condition variable thing I did. I think we have a lot of exciting things to explore here. So my time's about up. Okay, so just to draw this together, I think for one, in Perl6 we've made a lot of, I'd say, quite tasteful default trade-offs between static and dynamic, where we've said, well, these things, it really makes sense to try and decide as we compile and tell you about, and these things really want to be dynamic, and we really want to put them off. One of the things that's also curious is that by actually taking compilation, which is that very static thing, and saying we're going to allow a bit of runtime in there, we actually make it a lot more powerful. And kind of almost ironically, it's that very sort of great dynamism where we say even the language itself is mutable that ironically opens the door to a whole load of really interesting opportunities to do not just the boring static checking, like, oh yeah, you called this method on this object and that object didn't declare it had that method, okay? But a whole lot of much, much more interesting program properties that you really would not like to make it out there into your production environment. So thanks very much for listening. I probably use most of my time, but if I do have any left, I don't. 2 minutes? 4. 4. Okay, then I will have 4 minutes for questions. And if you're at the back, then please make noise instead of just wave your hand, because I don't see that far. And it's dark. Anyone have anything? Okay, one on the front here.
Is there any decent documentation of this aside from, you know, what we'll find on your blog slide?
For the meta model? Yeah, actually, docperl6.org now has pretty good API documentation on meta model stuff. So that stuff's covered, at least. And I think there's a document now that sort of describes the big picture stuff of it as well. So yeah, On some of the export stuff, I'm not quite sure what the state of the docs are, but if they're not what you want, please say. But the mop stuff, I know a lot of documentation got done recently. So.
Jonathan,
Yeah.
predict in our future there will be a really nice higher order Perl 6 programming book. That says how to do all of these cool things. It's not something you just pick up by reading the spec.
Yeah, I wonder who should write that. Please.
Is the did you mean $moronic or whatever?
Yeah.
Is that going to be less irritating than when Google does it? It does it to me all the time, and it's often enough wrong that I would much rather it didn't.
It's done with Levenstein, and it has a threshold on it.
Right.
So it has to be pretty close. And we actually, I think we even went and tweaked it and started weighting things like, you know, sigils to decide how they. So it has had some tuning.
Does it when you actually make a mistake? Whereas Google always does it.
Yes, and it only does it if your program is actually not going to compile anyway. So yeah, we've tried to make it not obtrusive but useful, and I think mostly people seem to like it. Yeah, okay, that's good. That's good. Please.
You said right at the beginning of the presentation that the error checking you were showing off was happening in the optimizer.
Some of it, yes.
Yeah, that was my question. Does that mean all of the error checking happens?
No.
Kind of
The type analysis bits. Right. I was meaning specifically. So you called this subroutine with these types. The actual reason that we're doing that analysis is not for particularly those cases. The reason we're doing it a lot of the time is because if we've got a load of multi-dispatch candidates and you're adding, say, two native ints together, we actually want to inline the sort of low-level plus operator, even though it's defined in a multi-sub. So we're actually looking for inlining opportunities and those sorts of things based on the types. And yeah, sometimes it just turns out the code you have to write to do that also produces all of the errors for that sort of thing. Most of the rest of it is actually much earlier in the pipeline. So, yeah. Yeah. One more?
When you were messing about with, I think it was export how or something like that, it looked like that was one package that deals with all of the classes. And then within that you check whether you were doing a particular class. Presumably if two modules want to do this, then they will fight over that package.
Yeah, there's an export how subpackage compose. The idea of compose is that you'll be able to have two modules that both provide, instead of classes, they provide roles. And what will happen is that the first point you actually try and use the thing, we'll sort of create a subclass of the currently enforced meta object. We'll compose those roles in that different modules have provided, and then we'll do the normal role composition algorithm on them. And then we'll be able to detect, meta-class conflicts. So that's the goal. That bit is specs. I didn't get to that one yet, but it's like 2 hours of programming when I catch a break. Okay, and that's my time up. Thank you very much.